Okay, so now, before we get into this example, the one thing that I want to say is that now we're using new terminology. Okay, so there's new terminology that has been introduced, and then we're going to be using that new terminology to restate things that we've been using previously. For example, Gaussian elimination, right? So now we know Gaussian elimination, or the Gauss's method, is by, we're trying to eliminate dependencies among the rows. Okay, so if we look at this example, we're eliminating, by transforming this matrix, we're eliminating any dependencies among the rows, but leaving the span unchanged until there's no non-trivial linear relationships that remain among the non-zero rows. So what Gauss's method produces is a basis for the row space. Okay, so in this example, that's what we're doing. So when we do our reduction, right, and if we do this, right, so we take negative row 1 plus row 2, and we take negative 2 times row 1 plus row 3, right? So what do we get there? So we'll get this new matrix. So let's do that, right? So row 1 will be unchanged, right? And then what do we get? We get 0, and then 1, and then we get 0, right? And then here we get 0, and then we get what? Negative 6, and then we get what? Negative 2, so we get 3. Right? Let's double check. Make sure I didn't make a mistake there. So negative 2 plus 2 is 0. Negative 2 times 3 is negative 6. Plus 0 is negative 6. And then negative 2 plus 5 is 3. Okay? And now, what are we going to do here? Well, we've got to get rid of the negative 6. Right? So what do? We do six. We do 6 times row 2 plus row 3. And then the first 2 rows are going to be left unchanged. So 1, 3, 1, 0, 1, 0. And then of course we end up with 0, 0. And of course we end up with just 3. Right? And we're done, because now it's in echelon form. And so this produces a basis. Right? And the basis is 1, 3, 1, 0, 1, 0, and 0, 0, 3. And that's for the row space. And it's the basis for the row space for both the starting and ending matrices, since the 2 row spaces, as we know, are equal. So using this technique, we can find bases for spans not directly involving row vectors. So again, using this technique, we can also find bases for spans not directly involving row vectors. Okay? That's where we're going to stop.